that rate of effusion is inversely proportional to square root of density of this gas. So this is valid only when pressure and temperature are kept constant. So we can write that when there are two gases in container, let's say there are two gases, gas 1 and gas 2, the rate of effusion of first gas is R1, rate of effusion of second gas is R2. We can write R1 by R2 is relative rate of effusion, right? So rate of effusion of first gas with respect to second gas, because we have written as R1 by R2. So R is inversely proportional to square root of density, which is inversely proportional to square root of molar mass. We can write R1 by R2 is equal to under root of d2 by d1 or square root of m2 by m. So now we'll solve another problem. 1.6 gram of CH4 effuses through a small pinhole in 60 seconds. Find weight of He gas effused out in 30 seconds under similar conditions. This is important point to note here, that pressure and temperature remain same here. We have two gases, CH4 and helium. 1.6 gram of CH4 weight is given. Molar mass for this gas is 16 gram per mole. You can calculate very easily. Time given is 60 seconds. For helium weight, we have to calculate how much it is effused out. Molar mass we know 4 gram per mole. Time given here is 30 seconds. So I'll ask you to pause this video for a moment and solve yourself. We know that rate of effusion is mole of gas effused out divided by time taken, right? So we can write R is N by T, moles divided by time taken. R for CH4 can be written as moles of CH4 divided by time taken by CH4. Here it is 1.6 divided by 16 divided by 60. Simple calculation, it will come out to be 1 by 600. Similarly for helium, we'll solve it. So we'll get W, which we have to calculate, divided by 4 divided by time taken. Here is 30 seconds. So it will come out to be W divided by 120. And we know that R1 by R2 is under root of M2 by M1. So 1 is CH4, 2 is helium, and we can solve this very easily. So we'll put these values, that is R of CH4 and R of He. We got these values. 1 divided by 600 divided by W divided by 120 should be equal to under root of 4 divided by 16, which will come out to be 1 by 2. So 120 divided by 600 W should be 1 by 2. So 240 should be 24 should be 60 times W. We can further solve it and get the value of W. It will come out to be 0.4 grams, right? So this will be our answer, the weight of He gas effused out in 30 seconds.